NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math tutorial, where we'll explore a fascinating algebraic problem. We'll see how to use algebraic identities to simplify expressions and find values based on given conditions. Let's start with our first example. Given the condition that x plus 1 over x equals 5, we need to find the value of x squared plus 1 over x squared. To solve this problem, we'll use an algebraic identity. The identity states that a squared plus b squared equals the square of their sum minus twice their product. We can write it as a squared plus b squared equals the quantity a plus b squared minus 2ab. Now, let's apply this identity to our problem. We'll substitute it equals x, and b equals 1 over x. Then, x squared plus 1 over x squared equals the square of the sum of x plus 1 over x minus 2 times x times 1 over x. Let's simplify this expression. 2 times x times 1 over x equals 2. And we know that x plus 1 over x equals 5. So our expression becomes the square of 5 minus 2. Now we can calculate the square of 5, which is 25, and subtract 2, which gives us 23. Therefore, x squared plus 1 over x squared equals 23. Let's move on to our second example. Given that x plus 1 over x equals a, and x is greater than 1 over x, we need to find the value of x minus 1 over x. For this problem, we'll use another algebraic identity. This identity states that the square of a plus b minus the square of a minus b equals 4 times a times b. Or we can rearrange it to say that a plus b squared minus a minus b squared equals 4ab. Now, let's apply this identity to our problem. We'll substitute it equals x, and b equals 1 over x. Then we get the square of x plus 1 over x minus the square of x minus 1 over x equals 4 times x times 1 over x. Let's simplify. 4 times x times 1 over x equals 4. And we know that x plus 1 over x equals a. So we have a squared minus the square of x minus 1 over x equals 4. Now we can solve for x minus 1 over x. We rearrange the equation to get the square of x minus 1 over x equals a squared minus 4. Taking the square root of both sides, we get x minus 1 over x equals the square root of a squared minus 4. We need to determine the sign. Since we're given that x is greater than 1 over x, we know that x minus 1 over x is positive. Therefore, x minus 1 over x equals the positive square root of a squared minus 4. In this tutorial, we used algebraic identities to solve two different problems. In the first example, we use the identity a squared plus b squared equals a plus b squared minus 2, a b to find that x squared plus 1 over x squared equals 23, when x plus 1 over x equals 5. In the second example, we use the identity a plus b squared minus a minus b squared equals for a b to find that x minus 1 over x equals the square root of a squared minus 4, when x plus 1 over x equals a, and x is greater than 1 over x. Here's a challenge for you before we end. If x plus 1 over x equals 6, what is the value of x cubed plus 1 over x cubed? Pause the video and try to solve it using the techniques we've learned today. You can use the identity a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Welcome to our lesson on solving an algebraic equation. Today we're going to work with an interesting problem that combines algebraic manipulation and substitution techniques. Let's consider our example problem. If x plus 1 over x equals, then what does x squared minus 1 over x squared equal? And we're given the constraint that x is greater than 1 over x. To solve this problem, we'll use a useful algebraic identity. The identity states that the difference of squares, a plus b squared minus a minus b squared, equals 4ab. This identity will help us manipulate our given equation to find what we're looking for. Let's apply this identity to our problem. We'll substitute a with x and b with 1 over x. So we get x plus 1 over x squared minus x minus 1 over x squared equals 4 times x times 1 over x. Next, let's simplify the right side. 4x times 1 over x equals 4. Now, we recall that x plus 1 over x equals a. So the first term on the left side is a squared. Before we continue, here's a quick challenge for you. Can you predict what the expression x minus 1 over x squared equals? Take a moment to think about it before we continue. Let's continue. We can rearrange the equation to solve for x minus 1 over x squared. We get x minus 1 over x squared equals a squared minus 4. Now, we'll take the square root of both sides. The absolute value of x minus 1 over x equals the square root of a squared minus 4. We need to consider the constraint given in the problem. If x is greater than 1 over x, then x minus 1 over x is positive. This means that the absolute value sign can be removed, and we have x minus 1 over x equals the square root of a squared minus 4. Let's pause for another quick challenge. Now that we know x minus 1 over x equals the square root of a squared minus 4, can you figure out how to use this to find x squared minus 1 over x squared? Take a moment to think about it. Let's continue solving for x squared minus 1 over x squared. We'll use another algebraic identity. We know that x squared minus 1 over x squared can be factored as x minus 1 over x times x plus 1 over x. Now, we can substitute what we know. We've found that x minus 1 over x equals the square root of a squared minus 4. And we were given that x plus 1 over x equals a. So, x squared minus 1 over x squared equals the square root of a squared minus 4 times a. For our final step, we'll simplify this expression. The product of the square root of a squared minus 4 times can be written as a times the square root of a squared minus 4. And this is our final answer. Let's summarize what we've learned in this problem. Welcome to this math video where we'll solve a problem involving quadratic equations and algebraic ratios. The problem states, if a squared minus 6ab plus b squared equals 0, and a greater than b is greater than 0, find the ratio of a plus b over a minus b. Let's start by understanding what we're given. We have the equation a squared minus 6ab plus b squared equals 0. Our goal is to find the ratio of a plus b over a minus b. Let's call this ratio r. We need to express it in terms of the information given in the equation. To make progress, we need to manipulate the original equation. Let's rewrite the middle term, negative 6ab. We can split it as negative 2ab minus 4ab. This might seem like a strange step, but it will help us create perfect squares in our equation. Now, we can use the perfect square formula, which states that a squared minus 2ab plus b squared equals a minus b squared. So in our equation, we can group the first three terms. A squared minus 2ab plus b squared, which is equal to a minus b squared. This gives us a minus b squared equals 4ab. There's another important algebraic identity we can use here. The formula states that a plus b squared minus a minus b squared equals 4ab. We can substitute what we know, that a minus b squared equals 4ab, into this identity. This gives us a plus b squared minus a minus b squared equals a minus b squared. Now, let's rearrange this equation. We can add a minus b squared to both sides, which gives us a plus b squared equals 2 times a minus b squared. Since a is greater than b is greater than 0, we know that both a plus b and a minus b are positive, so we can take the square root of both sides, giving us a plus b equals square root of 2 times a minus b. Finally, we can find the ratio of a plus b over a minus b. From our previous step, we have a plus b equals square root of 2 times a minus b. Dividing both sides by a minus b, we get the ratio a plus b over a minus b equals square root of 2. Therefore, the value of the ratio a plus b over a minus b is square root of 2. Welcome to our math tutorial. Today, we'll solve a problem involving radicals and algebraic manipulations. Let's take a look at our problem. Let's start by rewriting the original equation. We have the square root of x divided by x plus 1 equals 2/5. Our first step will be to take the reciprocal of both sides of the equation. This will help us isolate terms involving x. Now, let's expand the fraction on the left side. We can write x plus 1 over the square root of x as the sum of two fractions x over the square root of x plus 1 over the square root of x. Let's simplify the first term on the left side. X over the square root of x equals x divided by x to the power of 1/2, which equals x to the power of 1/2. And this is equal to the square root of x. To eliminate the radicals, we'll square both sides of the equation. But first, let's make an observation. Notice that the left-hand side has the form of a plus b, where a equals the square root of x, and b equals 1 over the square root of x. When we square this expression, we'll get a squared plus 2 of plus b squared. Let's see what happens when we square both sides. Let's expand the squared terms on both sides. For the left-hand side, we get the square root of x squared, plus 2 times the square root of x times 1 over the square root of x, plus 1 over the square root of x squared. This simplifies to x plus 2 plus 1 over x. For the right-hand side, we get 5 squared over 2 squared, which is 25 over 4. Now let's isolate the term x plus 1 over x. Subtracting 2 from both sides, we get x plus 1 over x equals 25 over 4 minus 2. Converting to a common denominator on the right side, we get 25 over 4 minus 8 over 4, which equals 17 over 4. Now, we need to find x over x squared plus 1. Let's multiply the expression x plus 1 over x by x over x to get x squared plus 1 over x. We know from our previous calculation that x plus 1 over x equals 17 over 4. So we can write that x squared plus 1 over x equals 17x over 4. Dividing both sides by x squared plus 1, we get x over x squared plus 1 equals 4 over 17, where we solve challenging math problems step by step. Today, we'll be looking at a substitution problem involving x plus 1 over x. Let's start by defining a substitution that will help us solve this problem. Let's call a equals square root of x plus 1 over square root of x. This is the value we need to find. To solve this problem, we'll need to find a relationship between a and the given information. Let's find a squared. A squared equals the square of square root of x plus 1 over square root of x. When we expand this, we get x plus 2 times square root of x times 1 over square root of x plus 1 over x. Simplifying the middle term, we get x plus 2 plus 1 over x. Now, we can use the given information. We know that x plus 1 over x equals 2. Let's substitute this into our expression for a squared. We get a squared equals x plus 1 over x plus 2, which simplifies to 2 plus 2, which equals 4. So we now know that a squared equals 4. To find a, we take the square root of both sides. A equals plus or minus 2. However, since a is the sum of square root of x and 1 over square root of x, and x is positive because we're taking its square root, a must be positive. Therefore, a equals 2. Now, let's verify our answer by checking if it satisfies the original question. We were asked to find the value of square root of x plus 1 over square root of x, given that x plus 1 over x equals 2. We found that this value is equal to 2. Let's move on to the second example shown in the image. We have, if x plus 1 over x equals 2, then find x to the power of 4 plus 1 over x to the power of 4. For this problem, we'll use a different approach. Let's start with what we know. If we square both sides of x plus 1 over x equals 2, we get x squared plus 2 times x times 1 over x plus 1 over x squared equals 4. Since x times 1 over x is 1, this simplifies to x squared plus 2 plus 1 over x squared equals 4. Rearranging, we get x squared plus 1 over x squared equals 4 minus 2, which equals 2. Now, we need to find x to the power of 4 plus 1 over x to the power of 4. Let's use the formula for the square of a sum. The square of x squared plus 1 over x squared is x to the power of 4 plus 2 times x squared times 1 over x squared plus 1 over x to the power of 4. Simplifying the middle term, this equals x to the power of 4 plus 2 plus 1 over x to the power of 4. We know that x squared plus 1 over x squared equals 2. So when we square this, we get x to the power of 4 plus 2 plus 1 over x to the power of 4 equals 2 squared, which is 4. Therefore, x to the power of 4 plus 1 over x to the power of 4 equals 4 minus 2, which equals 2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.